On August 3, 2025, a cluster of thunderstorms began to swirl and intensify over the warm waters of the central Atlantic Ocean. What started as a disorganized patchwork of clouds and rain quickly caught the attention of meteorologists monitoring satellite feeds from around the world. Within hours, these storms organized into a powerful system, Tropical Storm Dexter, the fourth named storm of the Atlantic hurricane season. Its rapid development was a clear sign that the quiet lull of early summer was over, and the atmosphere was primed for action. The formation of Dexter marks the beginning of the most active and unpredictable stretch of hurricane season, a time when the Atlantic's warm waters act as fuel for storms to grow stronger and more dangerous. Each year, as ocean temperatures climb, the risk of tropical cyclones increases dramatically, and Dexter was no exception. After a notably calm July, Dexter's sudden arrival was a textbook reminder that the tropics can change in an instant. The ocean, which had seemed so peaceful just days before, now braced for the possibility of turbulent weather ahead. The name Dexter was selected from the World Meteorological Organization's rotating list, joining the ranks of Arthur, Bertha, and Chantal in the official logbook for 2025. Each name on this list represents a unique story of nature's power and unpredictability. As soon as Dexter was named, meteorologists sprang into action, issuing advisories and tracking its every move. Early computer models brought a sense of relief. Dexter's projected path would keep it well away from major landmasses, sparing coastal communities from immediate danger. Still, for residents along the East Coast, especially in the densely populated Northeast, the storm's trajectory was a source of anxiety. People gathered around televisions and checked their phones for updates, wondering, where is it going? Will it come our way? Early forecasts showed Dexter curving away from the U.S. mainland, guided by prevailing winds and high-pressure systems that acted as a protective shield. This pattern, common during the peak of hurricane season, often determines whether a storm will threaten the coast or veer harmlessly out to sea. With this information, communities along the Atlantic seaboard were able to breathe a little easier. Still, the quick assessment served as a valuable drill, reminding everyone of the importance of preparation and vigilance as the season's most dangerous weeks approached. As Dexter began its journey across the vast Atlantic, meteorologists continued to monitor its progress with advanced technology, while coastal residents kept a watchful eye on the horizon, knowing that conditions can change rapidly. The arrival of Dexter signals that the peak of hurricane season is truly here. For those living near the coast, it's a powerful reminder that nature's forces are always at work, and that staying alert is the best way to stay safe. By Monday morning, August 4th, Dexter churned 255 miles northwest of Bermuda, far from the U.S. coast. With sustained winds near 45 miles per hour and a broad wind field, Dexter's reach extended over 100 miles from its center. The storm moved briskly east-northeast at 12 miles per hour, steered by powerful upper-level winds. Satellite images showed a somewhat ragged system, battling wind shear but still drawing energy from warm waters. Dexter's structure, imperfect but resilient, kept it classified as a tropical storm. For ships in the North Atlantic, Dexter's wide wind field and high waves posed real hazards. Swells radiated outward, creating dangerous marine conditions over a broad area. While no threat to land, Dexter was a force to be respected by anyone at sea. Its presence was a stark reminder of the ocean's power, even far from shore. Dexter's path isn't random. In fact, every twist and turn of the storm is shaped by the invisible hand of the atmosphere, following rules that meteorologists have studied for decades. It's dictated by powerful atmospheric currents, rivers of air that flow high above the surface, guiding storms like Dexter across thousands of miles. These currents are constantly shifting, but when they align just right, they can send a storm on a very specific journey. A large trough over the eastern U.S. and western Atlantic created strong southwesterly winds, steering Dexter northeast. This trough acts like a giant dip in the atmosphere, pulling storms away from land and out over open water. Think of Dexter as a cork swept along a fast-moving river in the sky, carried away from the U.S. coast. The storm has little control over its own movement. It's at the mercy of these larger forces. The Bermuda Azores High, a massive area of high pressure, also played a role, blocking any westward drift. This high-pressure system acts like a wall, preventing Dexter from turning back toward the U.S. and instead nudging it further out to sea. The result is a well-defined alleyway in the atmosphere, a corridor that pushes Dexter out to sea, far from populated areas. This setup is what meteorologists call a steering pattern, and it's crucial for predicting where storms will go. Meteorologists rely on sophisticated computer models to track these steering patterns. These models use real-time data from satellites, weather balloons, and aircraft to simulate the atmosphere and predict a storm's path with remarkable accuracy. In Dexter's case, the models were in strong agreement, a rare but reassuring sign. This rare consensus gave forecasters high confidence in the storm's harmless trajectory, allowing emergency managers and the public to breathe a sigh of relief. The science is clear. Dexter's fate was sealed by the atmospheric setup. The interplay between troughs, high-pressure systems, and jet streams left little room for surprises. For now, Dexter is what meteorologists call a fish storm, destined to trouble only ships and sea life, not people on land. Its winds and waves may be fierce, but they'll remain far from the coast. The U.S. remains safely out of its path, thanks to the powerful and predictable forces of our atmosphere. The National Hurricane Center's latest forecast made it clear. Dexter was racing east-northeast, charting a path that would keep it well away from any landmass. Meteorologists watched closely as the storm's projected track arced out over the open Atlantic, a relief for communities along the U.S. East Coast, Bermuda, and Canada. For days, there had been uncertainty about Dexter's intentions, but now the threat to populated areas had faded. Over the next 2 days, Dexter would pick up speed, accelerating into the cooler, deeper waters of the central Atlantic. The storm's eye, once a tightly wound vortex, would begin to lose definition as it moved farther from the warmth of the tropics. With each passing hour, Dexter would put more distance between itself and the North American coastline, remaining well clear of the U.S., Bermuda, and Canada. As Dexter entered these colder waters, it would lose access to the heat and moisture that fueled its power, much like a car running out of gas on a long, empty highway. The ocean's surface temperatures would drop, and the storm's towering clouds would begin to collapse, unable to draw the energy they needed from the sea below. The storm's structure would gradually unravel, its once organized spiral bands breaking apart. What had been a classic, well-defined cyclone would transform into a messy, fading, low-pressure area, its winds weakening and its core losing strength. The satellite images that once showed a powerful swirling system would now reveal a storm in decline. By midweek, Dexter would be absorbed by a larger, non-tropical weather system sweeping across the North Atlantic. Its remaining energy would blend seamlessly into the broader atmospheric pattern, becoming just one part of a much larger, more complex system. This process, known as extratropical transition, is a common fate for storms that venture into these latitudes. This is a typical end for many storms that find themselves caught in the powerful westerly winds of the North Atlantic. Here, hurricanes often lose their tropical characteristics and are swept away, their stories ending far from the headlines and the coastlines they once threatened. Dexter's brief existence as a named storm would close quietly, leaving no damage, no scars, and no lasting impact on the communities that watched it from afar. For those who tracked its progress, there was a sense of relief and gratitude that this storm's journey ended harmlessly, with the ocean as its only witness. Its story is one of a swift journey and a peaceful exit, a reminder that not every storm brings destruction, and that sometimes nature's power can pass by quietly, leaving only a memory of what might have been. For the 2025 hurricane season, Dexter is just a footnote, a name crossed off the list, remembered not for devastation, but for the calm that followed in its wake. Dexter's winds might briefly strengthen, but any intensification would be modest and short-lived. As it sped northeast, colder waters and increasing wind shear would sap its energy. Without warm water, Dexter couldn't maintain its thunderstorms or structure. By Tuesday, weakening would be steady and irreversible. By Wednesday, Dexter would lose its tropical characteristics, becoming a post-tropical cyclone. Its remnants would merge with another system, fading from the map by week's end. Dexter's story, a quick rise, a quiet fade. For Maine, Dexter poses zero threat, thanks to its distant formation and strong steering currents. A large atmospheric trough is pushing Dexter out to sea, hundreds of miles offshore and parallel to the east coast. There's no mechanism for a sudden westward turn. The pattern is stable and unbreakable. Local experts confirm no rain, no wind, no hazardous surf for Maine. The state's weather will be shaped by local systems, not Dexter. Unlike past storms that tracked closer, Dexter's path keeps it far away. The physics of the atmosphere make a Maine landfall virtually impossible. For the Pine Tree State, it's business as usual. Dexter won't even send high surf or rip currents to Maine's coast. Its swells are moving away from North America, leaving the Gulf of Maine untouched. No marine advisories are needed. Boaters and beachgoers can expect typical summer conditions. This storm is a textbook fish storm. All action, no impact for land. The lesson: not every named storm is a threat. For Mainers, Dexter is just a blip on the satellite, not a worry on the horizon. The week ahead promises calm seas and classic summer weather. Dexter's formation fits the forecast for an above-average 2025 hurricane season. NOAA predicted 13 to 19 named storms, and Dexter keeps the season on pace. The peak period, mid-August to mid-October, is just beginning, with warm Atlantic waters and La Niña conditions favoring more storms. Last year's destructive season is a reminder. Preparedness matters, even if one storm misses land. Dexter's harmless path shouldn't breed complacency. Now is the time to check supplies, review plans, and stay alert. The next storm, Erin, could be very different. Vigilance is the best defense as hurricane season ramps up. As Dexter fades, meteorologists are already tracking new disturbances in the Atlantic. Two areas of interest, one near Africa, one off the southeast U.S. coast, could become the next named storm, Erin. The system near Africa is a classic Cape Verde wave with a moderate chance of development as it moves west. Closer to home, a low-pressure area near Georgia and the Carolinas bears watching, even if its odds are low. Early August is prime time for new storms to form. Dexter's quiet journey is a welcome start, but the season is far from over. Forecasters remain vigilant, using every tool to track what's next. The heart of the 2025 hurricane season is just beginning.